It is time to look at section 1.3 in AP Statistics, and we are still talking about quantitative data, but in section 1.2, we talked about graphs that were appropriate. Now I want to focus a little bit more on the information that we need to measure, the center, the spread, and the potential outliers. So let's start with measures of center. There are actually 4 measures of center. There's the mean, the median, the mode, and the mid-range. However, the mode does not always exist, or it can exist more than once in a data set, and therefore it tends to be a little unreliable. So I won't even address it right here. Let's start with the mean. The mean is what most people just call the average, but you should never do that because technically these are all considered averages. Measures of center and averages are actually synonymous. So don't just call something an average, just pick the right word. Are you talking about the mean, the median, or the mid-range? So this is the official formula for the mean. And if you check out your formula page, it's probably on there. I don't think any one of you needs to look it up. But what it stands for is if every x value is a data value, then the I stands for a subscript. For example, this set, you could call this x sub 1, x sub 2, x sub 3, 4, 5, 6, 7, x sub 8. Sigma, means add things up. So this says add up all the x's and then divide by your n size. And the symbol is x bar. And remember, that's how you read that. That is x bar. And that stands for the mean. The mean is not considered a resistant measure of center because outliers or even extreme values will impact the mean. And I'll show you what I mean by that with this next example, no pun intended. The median is the value that splits the data in half. The median will use at most the 2 middle data values, and that's only in a data set with an even n size. So outliers and extreme values actually have no impact. And I put a little thing here, some older textbooks and resources, this X with the little tilde on front, some books use it for the median. Your book does not, but if you ever see it, that's all it stands for. All right, so here's 2 data sets. They're almost the same. They both have an n size of 8. They're almost identical, except for that one value at the end. That one value at the end is not going to impact the median. Okay, you might remember from middle school, we would find the median. We'd have all the numbers in order from smallest to biggest, and then you work your way in the middle. Do you remember doing this in middle school? Okay, and when there's 2 in the middle, technically what you're going to do is you're going to calculate the average between these 2. You're really going to do the mean of those 2 numbers. You're going to say, what is 7 plus 9? 16, and divide by 2 because there are 2 numbers, so the median is 8. And if you did the same thing on this data set, you get the same result. So even though this had a maximum of 15 and this one had a maximum of 150, it didn't matter. For the median, you jump right over it. So we say that the median, we say that it is resistant, okay? Because it resisted the 150. The mean is not resistant because watch what it does. You have to add all these numbers up, okay? You have to add all these numbers up, and then you need to divide by 8. All right, so let's see what we get if we add all those numbers up. We're going to take, how about we know that these 2 add to 14. We know these 2 add to 14. And we know these 2 add to 14. So I'm going to take 14 times 3, add the 7, and then add the 15. 64. But then I have to divide by 8, and that gives me 8. Now, you might say, Mrs. Fry, why didn't you just take the 15 and the 1 and the 13 and the 3 and say that those all add to 16? I could have. But down here, now the 150 doesn't follow that pattern. So I'm going to go back again and say, okay, there's a 14. There's a 14. There's a 14. So I need 14 times 3. I need to add 7, but now I need to add under 150. 199 divided by 8. Okay, and I get 24.875. A little bit different. So we say that the mean is not resistant, because if you were to think about in general, if this was the number of community service hours students had gathered, you could say on average our students get about 8 hours. But all of a sudden here, would you say on average our students get about 25 hours? Not really, because most of the students only get about 8. We just had this one crazy person who collected all these extra hours. So when you have an extreme value, we tend to avoid the median, and we tend to avoid the mean and we use the median instead. Now the mid-range, we talked about the mid-range in Algebra 2, and this is the formula, but it is not used as frequently in AP statistics. But I feel like as an AP stat student, you ought to know what it is. Now my question is, will the mid-range be resistant? And the answer is real simply, no. And the reason is, it can't get any worse. I don't care if there's an extreme value at the high end or the low end, the mid-range is going to use it. So the mid-range is going to be impacted by any extreme values that might be somewhere in that data set. So the mid-range is not resistant. It uses potential extreme values or outliers. You should understand the mathematical implications of the mean. Consider the first data set above. For every value that you have that is above the mean, 9 is 1 above, well, then you have a value that's 1 below, 7 is 1 below. 11 is 3 above, 5 is 3 below. 13 is 5 above, 3 is 5 below. Okay, everything has perfect balance. Now, even if it doesn't balance out 1 for 1 like that, what the mean does is for every little bit that's above, there has to be something to counterbalance it below. So your mean on this data set is actually somewhere in here. It's somewhere between 13 and 150. It takes all of these values below the mean to offset this one value that's above the mean because of this outlier, okay? When you take the AP exam, there are going to be times that they're going to ask you to describe what the mean represents. And throughout this class, you're going to get these boxes from me, and I call it AP phrasing. And these are things that you could memorize to use on the AP exam. And what I do on these is I give you what you could write in regular font, but then in brackets and italics, you're going to fill that in. So you could say if all of the values of, okay, again, let's say these community service hours. If all of the values of community service hours had been the same, that value would have been 8 hours. That's me describing this one right here. Now that might sound weird to you, but it's true. Because if every one of these people had had exactly 8 hours, well, then you would have come up with the same value, 64 divided by 8.